Hello everyone and welcome back to my channel Gyan Sampada. From last few classes we are discussing about semiconductor devices where we have already completed the discussion on tunnel diode, gun diode, semiconductor lasers, etc. And today we are going to start with another new topic, or you can say another new semiconductor device which is of very high importance in our day-to-day life, that is light emitting diode. It is clear from the name that light emitting means there is a emission of light from the semiconductor device, and diode means it is a device used for unidirectional flow of current. Moving to its history, we need to go into 1900s and understand some of the earlier developments which laid the foundations for invention and the development of semiconductor materials, especially LEDs. The chronological order is already given here. You can pause the video and have a look at it. So we will switch over to the next topic, which is related to the MSc level of physics, that is LEDs, or also called as semiconductor lamp. Diode is nothing but a PN junction, that is a two-terminal device which allows the current in only one direction. PN junction is nothing but a junction of P-type semiconductor and N-type semiconductor. So today we are going to deal with its operation, construction, the factors which are going to influence the efficiency, as well as some of the uses. So semiconductor lamp is a semiconducting PN junction which is properly biased and serve as a light emitter, that is a semiconductor lamp. So diode is a basic concept. Thus I will move on to the next details. These lamps are also called as LEDs, that is light emitting diode, as it is having several advantages over the conventional lamps, like it has a much greater emission power per unit volume, greater ruggedness, and can be built at a lesser cost. LEDs can be modulated much more rapidly, so easy tuning is possible. And some other advantages, like it is environmental friendly as well as it is reliable, as it is having a longer life. So to list out the advantages, there are a number of advantages, out of which some important advantages are listed here. So next we will move on to its operation and the working. Mainly its circuit symbol is shown here, where this triangle with a line is a symbol of a diode, where this is a P side and this side is N side of the junction. This is a symbol of LED, and here we can observe that there is emission of light mainly from the junction region. So let's understand about the operation of semiconductor lamp. Here the LEDs operate below the lasing threshold and light is emitted as incoherent radiation. So if you want to understand about its construction, LED consists of a forward biased PN junction, which is clear here. Forward biased means P side of the semiconductor diode is connected to the positive terminal of the battery and N side is connected to the negative terminal of the battery. This condition is called as forward biasing. And if you have gone through the previous class where we had a discussion about semiconductor laser, there also we used the forward biasing condition only. So for both semiconductor laser as well as LEDs, that is semiconductor lamp, forward biasing of the PN junction is very important. With respect to energy level diagram, the operation is observed here, where there is a conduction band. This is the valence band of P side and N side. The holes are present here and the conduction electrons are present in the conduction band. and from the depletion region where the junction is present, we can observe light coming out. This shows the variation of Fermi level with respect to P and N side and along the depletion region. So if we observe here, the electrons are injected from the N region across the depletion layer and into the P region, where they recombine with the majority carriers, that is holes, thereby emitting radiation from the diode. And simultaneously, holes are injected from P to N region, where they recombine with the electrons, again contributing to the emitted radiation. So this is how the operation of LEDs is occurring. So in the depletion region, the recombination of hole and electron is responsible for emission of light from the junction. So then moving to the factors which are going to influence the operation or efficiency of LEDs. The first prime factor is the energy gap. So energy gap is nothing but the energy difference between the minimum of the conduction band and the maximum of the valence band. And to understand in more detail, you can refer to the semiconductors playlist, where separately we have explained the energy gap even with respect to the real semiconductors like gallium arsenide, silicon as well as germanium. So how the values are present, what are direct and indirect band gap semiconductors, everything will become clear over there. So now keeping in mind that you know about those details, let us continue here. This is how the LED is going to look. This is the outer shell. Inside you are having the diode, and in the depletion region, due to recombination, you can observe the emission. So moving to the influencing factor, that is energy gap, we know that energy gap or energy is equals to h into nu, where nu is the frequency, h is Planck's constant, and nu can be written as c by lambda. Clearly we can observe that the energy gap is inversely proportional to wavelength, which means that energy gap determines the wavelength of radiation which is emitted from the diode. For example, gallium arsenide is having an energy gap of 1.35 electron volt, let us say. It means that the corresponding wavelength which it is going to emit is going to be equal to 0.9 micrometers, and this wavelength lies in IR region. So we can say that gallium arsenide is going to emit infrared radiation. So another example is gallium phosphide, where energy gap is 2.25 electron volt. So we can observe energy gap has increased, due to which wavelength is going to decrease, and that wavelength comes in the visible range of the electromagnetic spectrum. So as the band gap changes, the corresponding wavelength of emitted light also changes, and we can have different radiations emitted in different regions of electromagnetic spectrum, and that can be utilized for different types of applications. Moving to the second factor, that is internal quantum efficiency. Here, an electron and hole pair may be recombining in two ways. One is a radiative recombination and another one is non-radiative. Radiative recombination means in this recombination process there is an emission of photon, whereas if it is a non-radiative recombination, there are several intermediate steps where the energy is lost in the form of heat. So we can't expect the emission of photons. So in an efficient device, radiative process must be dominant so that more number of photons are emitted and most of the energy is converted into light. So losses are reduced and output is more. Moving to the meaning of quantum efficiency, it is nothing but the ratio of the radiative to non-radiative transitions. So if we want the efficiency of LED to be high, it means that the radiative transitions should be more when compared to non-radiative transitions. That is, numerator should be greater when compared to denominator. So we will have more number of photons emitted and it gives a higher quantum efficiency. So most of the energy is converted into light. There will be some other losses like loss due to Joule heating, which can be minimized also. Then moving to the band structure, and this structure again influences the quantum efficiency. That is, radiative recombination and excitation are strongest in direct band gap semiconductor. For example, gallium arsenide. So recombination in indirect semiconductors like silicon, germanium, etc. takes place by intervention of phonons, which reduces the transition probability because that phonon is going to provide the extra momentum to reach from valence band to conduction band. Thus, direct band gap semiconductors are preferred for semiconductor lamps. These are the most important influencing factors which will define or which we will express the efficiency of semiconductor lamp. Then some other factors that are of prime importance are, first one is tuning. According to the requirements or the applications, the tuning can be done in semiconductor lamp by alloying method. Like gallium arsenide emits a radiation which falls in infrared region due to its small energy gap. And if the energy gap is widened by alloying with gallium phosphide or any of other kind which is having a wider band gap, the radiation falls into the visible range and that is of more application. So in this manner, tuning is very helpful for application purposes. So alloying is the method corresponding to that. Next is the total internal reflection of radiation at the surface, which is again going to influence the overall efficiency. And lastly, about the uses or application. Mostly the semiconductor lamps or LEDs are used in display devices. The list you can observe here and it is evident in our day-to-day life also. So for illumination, display, indoor farming, disinfection, microscopes, here for different types of application, different types of semiconductors are used. Because for disinfection, you may need different wavelength when compared to the display devices. For display devices or for the decoration purposes, we need the radiation coming out in visible range only. But for other purposes, the wavelength is going to vary. So according to that, tuning is done by alloying, and as per the requirements or as per the device fabrication or as per the applications, the LEDs can be manufactured. So these are some of the details about semiconductor lamp or LEDs, just which are most important and of more weightage. However, other details about LEDs can also be added according to the requirement. So this is it for the today's class, and in coming class we are going to study about the photocell and its operation, significance, working, etc. How the semiconductor devices are playing a very important role in our life is going to be more evident by our coming classes. So till then, stay tuned, go through more details about the semiconductors as well as semiconductor devices. For more clarity, you can visit the playlist section of my channel. Till then, study well and thank you for watching.